Hello, Matthews Gatos here. In this video, we're covering section 3.1, velocity. So to figure out velocity, we need to first work on our position function. So S of t tells you where an object is at any given time t. When our position function S of t is positive, greater than 0, means the object is moving to the right of the initial position. When our position is negative, it means the object is moving to the left of the initial position. And when we have S of 0, meaning that I've substituted in time for 0, that's the initial position of my object before I start my time. Let's talk about the difference between average velocity and instantaneous velocity. Average velocity is an average rate of change over some interval of time from A to B. It is the slope of a secant line to the position curve. So a secant line has 2 points. So I take the distance and time of one point, and I take the distance and time of another point, and I can do the slope. So it's going to be the change in distance over the change in time. Now, instantaneous velocity is how quickly the object changes from one position to another. It is the slope of a tangent line to the position curve. So tangent meaning there's only one point. So since there's only one point, we can't calculate slope directly. We can either use tangent definition number 2, which is the limit function. So the limit as h, the horizontal distance between a tangent point and another point, approaches 0, or we can just take the first derivative of the position function. Let's look at some notes on velocity. So when velocity is positive, that means that the object again is moving away from the initial position. If it's negative, it means the object is moving towards the initial position. And when the velocity is 0, it means that the object has stopped moving altogether, or it has changed directions. And of course, before I change directions, I have to stop moving and then change directions. So comparing the two, your position function has linear units. Linear meaning meters, kilometers, centimeters, etc. Velocity has units for time, units versus time. So it's a rate, meters per second, kilometers per hour, etc. And just remember that velocity is the derivative of the position function. So let's try an example. We have an object that is fired from a cannon straight upwards at 16 meters per second, and its position function is given as follows, where time is greater than 0. I want to find the velocity after 1, 2, 3, and 4 seconds. So before I can find the specific velocity, I need to find the velocity in general by taking the derivative of the position function. So velocity is going to equal to the derivative of 16t is 16. Take away the derivative of 4t squared is 8t. So that's my velocity in general. So now if I want to find the velocity at 1 second, I just replace t with 1. So I'll have 16 take away 8 times 1. So at 1 second, my velocity will be 8 meters per second. So moving away from my initial point. At 2 seconds, substituting in 2, I have 16 take away 8 times 2. So that would be 16 take away 16, which is 0 meters per second. So that means that the object has stopped moving. At 3 seconds, I would have 16 take away 8 times 3. And that would equal to negative 8 meters per second. Now that makes sense because at 2 seconds I stopped moving, and at 3 seconds I'm doing a negative velocity, which means I'm moving back to my original position. And then at 4 seconds, 16 take away 8 times 4, still have a negative velocity, and that would be at negative 16 meters per second. Okay, let's now look at the maximum height of the object. So a maximum height occurs when the object stops moving. So it has to come up, and for a split second it stops moving before it comes back down. So we already saw in the last example that the velocity was 0 when time equals to 0. So I know at 2 seconds the object stops moving. To figure what the maximum height is, I take that 2 seconds and substitute it back into the position function because I want to know what the height is going to be. So substituting it back into my position function, which was 16 times t, but of course t is 2 seconds now, minus 4 times t squared. So that means that my position at 2 seconds, so my position at 2 seconds is going to be 32 minus 2 squared is 4 times 4 is 16. So my position at 2 seconds will be 16 and my units would be meters. So it would be 16 meters at the maximum height. Let's look at the next part. What is the velocity when the object reaches the ground? So when the object reaches the ground, that's when the position function has a y value of 0. So I want to figure out how long does it take for the object to reach the ground again, and then I can figure out what the velocity is when it hits the ground. So s of t will equal to 0. So our position function was 16t minus 4t squared. I want to know when that is equal to 0. So let's solve this by factoring. So greatest common factor of 4t, 16t divided by 4t is 4. 4t squared divided by 4t is t. And I want to know when that is equal to 0. So I'll set each one equal to 0. So 4t can equal 0, or 4 minus t can equal 0. Oh, I'm having problems with my pen here. Let me just see if I can switch. So 4 minus t equals 0. So over here, divide both sides by 4, and I get time equals 0. Here, add t to both sides, and I get time equals 4. So time equals 0, that makes sense because this is when I start. And then time equal to 4 is when I end, so when I hit the ground. So it's going to take 4 seconds before I hit the ground. So now I want to figure out what my velocity will be at 4 seconds. So my velocity at 4 seconds, go back to your velocity equation, which was 16 minus 8t, but now t is 4. So this will be 16 take away 32, which is negative 16 meters per second. So when it hits the ground, it's hitting the ground at a velocity of negative 16 meters per second. Okay, let's look at this one here. So we have a position of a particle given by the position function, and distance is in meters, time is in seconds. So looking at this position function, it asks you what the initial velocity is. So, well, let's start with what the velocity equation is. So velocity is equal to the first derivative of the position function. So velocity at t is equal to the derivative of the position function. So that would be the derivative of 2t cubed would be 6t squared minus the derivative of 21t would be 42t plus the derivative of 60t would just be 60. Okay, so now that I know what my velocity function is, I just have to substitute in 0 because the initial velocity, initial means when time is 0. So my initial velocity is equal to 6 times 0 squared minus 42 times 0 plus 60. So everything except for the 60 goes away. So that means that my initial velocity is 60 meters per second. So when I start my time, the object is already moving at a velocity of 60 meters per second. Second part of this question asks us, when does the object change direction? So remember, the object changes direction when it stops. So it has to stop first, and then it can go in the opposite direction. So for it to stop means the velocity has to be 0. So I want to find the times when my velocity is equal to 0. Let's try that again. When my velocity is equal to 0. So my velocity equation was 6t squared minus 42t plus 60. I want to know when that is equal to 0. So I'm going to solve this by factoring. So first thing I notice is that I have a GCF of 6 that I will take out. And then I just factor my resulting quadratic. So t minus 5 and t minus 2 equals 0. So I have two sets of factors that I will set to 0. So when I set this one equal to 0, while dividing both sides by 6, I just end up with t minus 5 equals 0. So that would be 5 seconds. And this one, solving for that, add 2 to both sides, and I get a time of 2 seconds. So that means that it changes direction at 2 seconds and again at 5 seconds. So now that I know when it stops to change direction, I want to look at when it has a positive and a negative velocity. So over here, I have my factored form, and I have when it is equal to 0 at 2 seconds and 5 seconds. So really what I'm doing is splitting it into 3 separate intervals. I want to know what's happening, obviously 0, starting at 0 when I start the time, between 0 and 2 seconds, between 2 and 5 seconds, and 5 seconds and beyond. So what I'm going to do is I'm going to use sign analysis. So everything is in factored form. Now 6 is a constant factor. So regardless of the interval, 6 will always be positive. Let's look at our other factors. So for example, t minus 5. Now t minus 5 is 0 when t equals 5. So what that means is that's the x-intercept of that factor. So to the left of that x-intercept, my factor will be negative. To the right of that factor, my factor, or to the right of that value of 5, my factor will be positive. So you can do this through substitution or just a quick sign analysis. On my next one, t minus 2, it's 0 right here at 2. So to the left of 2, my factor will be negative. To the right, it will be positive. Now, velocity is the product of those factors. So let's do the product of these signs. So here I have 2 negatives, which make a positive. Here I have 1 negative, which is a negative, and all positives is positive. So I am going to have positive velocity between 0 and 2 or beyond 5. So I'm going to say 5 to infinity. Now I have to place my brackets. I know at 5 seconds my velocity is 0, which is neither positive nor negative, so I use a round bracket. I can't technically equal infinity, so that also has a round bracket. I know at 2 seconds my velocity is 0, so again that's neither positive or nor negative. But I do know when velocity is equal to 0, that was my initial velocity, which was 60 meters per second. So since I know that my initial velocity was 60 meters per second, that is a positive number, so I can include 0. And then my negative velocity will be in between 2 and 5. And I can use rounded brackets for that. So that's when it would be positive and negative. Positive moving away from the initial point, negative moving back towards. Okay, so again, just a little note there that I used a square bracket for 0 because the initial velocity was 60, which was a positive number. Okay, next part of this question, we want to find total distance and displacement within the first 10 seconds. So within the first 10 seconds, I have to start at 0. Then 2 seconds and 5 seconds are important because that's when I stop moving. And then 10 seconds because I want it within the first 10 seconds. So I want to figure out the distance the object has moved at each one of these. So since I want the distance, I go back to my initial position function. So at a time of 0, I just replace all my t values with 0, and working that out, I just get 0 meters, which makes sense. At 0 seconds, it's traveled 0 meters. Now at 2 seconds, I substitute all my t values for 2. I see that I've traveled 52 meters. So I've gone from time 0, 2 seconds later, I'm 52 meters away from my initial position. I do the same thing for 5 seconds, and I have 25 meters. So that tells me I must have changed direction and I'm coming back closer to my initial position. And then at 10 seconds, substituting that in, I have a larger number, 500. So again, I've changed direction. And remember, we know that we're changing direction at at 2 and 5 seconds. So that's why there's a change in the distance from the initial point. Now, if I want to know displacement is the difference in the distances from start to finish. So where did I end? Subtract where did I begin? So if I want to look at that in terms of, and this is why we figured out all of that displacement on our chart. So if I want to look at the total displacement, I'm going to look at where the position was at 10 seconds, subtract where the position was at 0 seconds. So based on that table that we just looked at 10 seconds, I had a distance of 500 meters. Subtract the distance at 0 seconds was 0 meters. So that means that my displacement of the object is 500 meters. Now that's not the same as the total distance because there was a lot of back and forth. So the total distance is the sum of all the absolute values of distances between all the turning points. So let's look at that. So to do this, I am going to look at the distances for each of those intervals. So for the first interval, I'm looking at the distance between 2 seconds and 0. So ending at 2, beginning at 0. So that would be the absolute value of 52 take away 0. Add that to the end position at 5 seconds, which was 25 meters. Subtract the end position at 2 seconds, which is 52. Add that to the position at 10 seconds, which is 500 meters. Subtract the position at 5 seconds. So this is giving me the distances between each one of those intervals. So I'm going to end up here with 52 plus, this is negative 27, but I take the absolute value, so it's positive. And this is 475. So this is adding all the back and forth movement. The total distance the object has traveled altogether, 554 meters. The last thing that I want to do is just graph the positive and negative velocities so we can kind of get an idea of what's happening with this object. So we're going to put everything together, and I'm going to do that on a position curve. Now I know for the first 10 seconds I go to 500, so clearly I don't have up to 500, so we're just going to extend the graph. So let's look at our very first interval between 0 and 2 seconds. So I started time 0 right here with a position of 0. And within the first 2 seconds, I traveled a distance of 52. So I end like right about there. Let's say that's 52. So this would be my motion going in this direction here. And that would be from time equal to 0 to time equal to 2. And I know in here, I have a positive velocity because I'm moving away from my object. Okay, at 2 seconds I stop because I turn around. So between 2 and 5 seconds, I am going from 52 meters. I'm going to end up back at 25 meters. So I'm going to go back this way and end up right about there at 25. So this would be at time equal to 5 seconds. So in this one here, because I'm returning back to my initial position, I know that I have a negative velocity. So this will be negative velocity. And then 5 seconds to 10 seconds. So I start at 5 seconds and I extend all the way. I'm going to keep on going. Okay, dot, 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 until I reach 500 meters. So really off my grid there. And that will happen at 10 seconds. So since I'm moving away from my initial position, this has a positive velocity. So you can see what I'm doing here. I'm starting at my position. I'm going to the right. I stop, change directions, go to the left, stop, change directions, and then go to the right and end at 500 meters. So that would be kind of the pathway that our object has traveled. So that's kind of what I wanted to cover in velocity, but I do have a question for you. Do you know what distractor divided by time raptor is? So distractor divided by time raptor, almost like distance divided by time. Well, hopefully today's lesson was a big clue. It would be velocity. So distance over time is velocity, but in terms of raptors, I would end up getting a velociraptor. So you guys can do your practice questions, page 124, number 1, number 3 to 9. I hope that this video helped, and I look forward to seeing you guys for the next one.